Hi everyone. In this last video about section 2.3, which involves lines, we're going to talk about special lines. So we've already talked about two special lines, the horizontal line and the vertical line earlier on, but now we're going to talk about pairs of lines and sort of properties of different pairs of lines. Okay, and specifically we're going to talk about two different special properties, parallel and perpendicular lines. When two lines do not intersect over like the whole plane, because you know they go in either direction all the way to infinity, okay? When two lines don't intersect, they are parallel. Okay, so the parallel lines are lines that do not intersect on any of the xy plane. So there's a theorem here that has criteria for being a parallel line, and it says two non-vertical lines are parallel if and only if their slopes are equal. Okay, so that's important. Slopes are equal and they have different y-intercepts. Okay, so their slopes have to be equal and they have different y-intercepts. So again, it's going to be easiest for us if we look at the equation of this line in slope-intercept form. Okay, so what this says, or as we have in an example here, if I have y equals 2x plus 3, and then I add a second line, y equals 2x plus 5, these two lines are parallel because they have the same slope and they have different y-intercepts. Okay, if I have the same slope and the same y-intercept, then I have the same line, not parallel lines, but the same exact line. Okay, so y equals 2x plus 3 and y equals 2x plus 3. Those lines aren't parallel, they're just the same line. Okay, so that's what it means by having equal slopes and different y-intercepts. If you don't have different y-intercepts, then you don't have different lines. Okay, so show that. So a common task that I might ask you to do here is to show that the lines y equal 2x plus 3 equals 6, 2x plus 3y equals 6, and 4x plus 6y equals 0 are parallel. Okay, so to show that, you have to show that they have different, same slopes and different y-intercepts. So we just need to solve in terms of slope-intercept form. Okay, so get these standard form equations into slope-intercept form equations and see if the slopes are the same and we have different y-intercepts. So let's solve each one in turn. We'll start with 2x plus 3y equals 6. We want to get y by itself, so we subtract 2x there, and then we divide by 3. That leaves us with y equals negative 2/3 x plus 2. Okay, the 3 goes to the 2x and to the 6. So that's one. Let's start the other one. 4x plus 6y equals 0. Subtract 4x. 6y equals negative 4x. Divide by 6. And I get y equals negative 2/3. Sorry, that was really bad writing. Negative 2/3 x. Are these lines parallel? Well, they have the same slope, and they have different y-intercepts. So the y-intercept of the left side equation here is fairly easy. It's 2, okay, or really 0, 2, okay? But what about the equation on the right? Does it have a y-intercept? Because there's no plus anything. It turns out it does have a y-intercept. It's just sort of hidden because it's really plus 0. So the y-intercept for this is 0, 0, or what's called the origin. Okay, the origin of the xy plane is 0, 0. So they are parallel. Same slopes, different y-intercepts. Okay, so those are parallel lines. Now let's talk about perpendicular lines. When two lines intersect at a right angle, they are called perpendicular. Okay, so if we go back actually to parallel lines, graphically, they're going to look like this. Okay, now imagine if all of those lines were straight, not crooked. Okay, they're going to hit the y-axis at different points, but they sort of rise and run at the same amount the entire time, so they'll never hit each other. Okay, so perpendicular lines, or lines that are perpendicular, are going to intersect each other at a right angle. So what's the criteria for a perpendicular line? Well, two non-vertical lines are perpendicular if and only if, okay, the product of their slopes is -1. Product of their slopes is -1. Okay, so if we look at the line y equals 3x plus 2 and the line y equals -1/3 x plus 4, it turns out that these two lines are perpendicular because when I multiply their slopes, 3 times -1/3 is equal to 1. Sorry, -1, which is what we want. Okay, so here is a task for you. Find the equation of a line that contains the point 1, 2, and is perpendicular to the line x plus 3y equals 6, and then graph the two lines. Okay, so this is a little bit more of a substantial problem, okay, than our parallel lines one, but it is one that we can do. So we want to find our strategy for this problem is one going to be finding the slope of the original line, which is this, 2, use the point and slope form to find the equation of the line, and then lastly we're going to change to slope intercept form. Okay, I know that's bad writing, but hopefully that sort of makes sense. So the slope of the original line, we need to find x plus 3y equals 6, subtract x, 3y equals -x plus 6, divide by 3, and so I get y equals -1/3 x plus 2. Okay, so that's the original line. Now I need to find, I want to find the equation of a line that's perpendicular to this one. And so to be perpendicular to this one, I have to find a number such that when I multiply by -1/3, I get -1. And so we actually saw this in my last example that I did. That number is 3. So that's the slope of my new line. Okay, so my new line is a line that goes through 1, -2, and the slope is 3. So we use a point slope form, which is y minus y1 equals the slope times x minus x1, which is 1. Okay, so then I have a y plus 2, because these change to pluses, equals, when I distribute, 3x minus 3. Okay, And then to get it in slope-intercept form, I just subtract 2 from both sides, and I get y equals 3x minus 5. Okay, so that is the equation of my new line. That's the equation of my new line. So here I have two lines, y equals negative a third x plus 2, and y equals 3x minus 5. Okay, and I can graph them. I don't have a lot of space here, so I'm going to get rid of this top stuff here and the work except for the actual line. And so let's graph these two things. So there's my xy plane. Just count off by a bunch in all 4 directions. Okay, so we'll start with this equation here. Y equals negative a third x plus 2. We start at the y-intercept of positive 2 here, okay, and then we go down 1 and to the right 3. Okay, so I will put the negative in the top of this, so negative 1 over 3. So it's down 1 to the right 3. Down 1 to the right 3. Okay, so that gives us 3 points, which should give us a decent line. Okay, so that's line number 1. Let's look at line number 2. We'll go blue for it. Okay, y equals 3x minus 5. So that means we start at negative 5 for our intercept, and our slope is really 3 over 1, okay, which is a rise of 3 to the right 1. So I go up 3 over 1, then again up 3 over 1, up 3 over 1. And that gets us a decent line, although my drawing is not great. And you'll see that at the intersection point here, which I'll put in green, that it looks like it intersects at a right angle, which is what we want. Okay, so those lines are perpendicular. So for your turn, okay, I have 2 lines here, y equals 1/2 x minus 3 and y equals negative 2x plus 4. I want you to determine if those lines are parallel, perpendicular, or neither. Okay, it has to be one of the 3. It can't be parallel and perpendicular at the same time. Okay, so they're either parallel, perpendicular, or neither. So write which ones they are and justify why. Okay, that's the end of this video and the end of section 2.3.